Hello and welcome to Ask a Nerd. Now, what might the perfect mobility solution look like? Maybe a car that never needs charging. With the advent of electric vehicles, we have an opportunity to charge those vehicles wherever electricity is available via a plug point. Away from a plug point, we also have an additional opportunity with the move to electric vehicles. There's a massive energy source in the sky. The question is, how useful can that be, and how does that integrate into the electric vehicle infrastructure? Today, we're going to be talking about solar power with electric vehicles. So I'll hand you over to Cecile to introduce our nerd for the day.
Hi, everyone. So obviously, when you think about electric vehicle, you associate solar energy and renewable, and it seems like a nice idea. So very often on social media, you see this picture where you have a solar panel and people imagine they can charge their car forever. Would it be the car charging from the grid, or would it be directly on a solar panel integrated on the vehicle? But is that realistic? This is what we are going to talk about today. So before I present our speaker, how is it organized? We will have some educational content talking about solar technology for electric vehicle. We will have 3 case studies. We will talk about the Sono motors, the Lightyear and the Aptera. We will talk about some future solar panel trends. And then we will get some question in the last part. So our guest today, welcome, is Jon Ngiam. Hi, Jonathan.
Hi.
Can you present for people?
Hi. Yeah, hi everyone. My name is Jonathan. I'm part of Voltshare. Just presenting today to talk to you about solar-powered electric vehicles, the technology surrounding them, and whether it is the key to range-free anxiety.
And what sort of background do you have? Usually people like to know how you end up in the...
So my background is originally in material science and engineering. Then I did research in solar energy in Imperial College, where I looked into certain novel materials for new solar technologies. So for instance, one of them is the hybrid inorganic-organic perovskite solar cell. One of the key advantages to that is, which I can talk about later, is that they are completely solution process. So technically speaking, you can paint them on any surface, but of course there are lots of technologically barriers that we have to overcome for that to actually happen.
Okay, so I see you are a very technical person, so I can ask you a lot of questions for solar panel. So solar panel are very trendy for EV, of course, because it works together, but also to be directly integrated on electric vehicle. And we see a trend at several car manufacturers to get that. So for example, mid of July last year, we have seen that Tesla filed a patent, for example, on a solar panel, which is retractable, possibly for their Cybertruck. But we have also a lot of other car manufacturers trying to use this technology for the electric vehicle. So when we prepare these slides together, we put several car manufacturers, but there are actually quite a lot. Some of them are, I'm going to say, new, like Lightyear or Sono motors are quite new. Fisker is also quite new, but some of them are has a lot of experience, like a Hyundai. And actually, solar panel has been used in also traditional car to alimentate accessories for quite a long time, more or less successful, I would say. And we also know that it gets a lot of implication. I don't know if you have worked on this sort of integration, Jonathan.
Not directly. My expertise is more in the fundamental basics of solar technology. These would surround more electronics specialty, but things like MPPT, yes, I have dealt with that in some sense.
So for the electric vehicle, there are 2 ways to consider how the solar panel can play a role. Either they would be charging for the grid. So in this case, you plug the solar panel on the grid and your car can charge directly from the solar panel or from the grid. this means that you will have to treat a certain part of electronic with DC-DC converter and things like that. Also, a part we are not really addressing here is the fact that you can use batteries as second life, so they can store a part of the solar energy, because sometimes you have this energy you do not want to use directly, so you can store that in batteries, and this is a way to recycle some of the batteries in this way. And as I say, another part is possibly to integrate directly this solar panel on the vehicle itself. In this case, we are not going to detail that, but in this case, it's become slightly more complicated because you will have to interact directly with the battery of the car, but also maybe to get bidirectional charging. Sometimes it can go directly for the battery, sometimes it can go to the grid, and it will involve a lot of electronic, a lot of DC-DC converter, inverter, and things like that. So one question I have for you, Jonathan. Let's talk about the fact if it's realistic to think that one day we could power a car solely based on solar energy. Because in England, if I take what we have, roughly speaking, I can generate 1,200 kilowatt-hour per square meter per year. Mm-hmm. And in England, it's not the best weather possible, so the efficiency is not always that good. And I have estimated that in England, I could, for example, on a Ioniq, make 1,400 kilometers, which I think is not so bad. Mm-hmm. Knowing that on the absolutes, when you look at the specification given by Hyundai themselves, they estimate that the best case scenario, which means living in the south of Europe or even in Africa, they estimate the maximum could be 2,000 kilometers. They estimate this is the maximum autonomy. And we are still far from what we need. So do you believe it's possible by pushing this to achieve one day something enough to drive a car reasonably on a certain amount of kilometers?
I suppose the question is, how far are you willing to wait in between driving and allowing the sun to charge your car? Because if you're talking about purely on a day-to-day basis driving without any hindrance to your daily life, solar charging fundamentally would not be able to provide that energy fast enough for you to drive and commute without any hindrance. The main reason for that is because the fundamental limit for solar cells is about 33%. That's theoretical limit. So there are ways for you to increase that limit, but I guess we'll just stick to with traditional solar cells, which currently are around 19 to 22%. So that means that if the sun provides 1 kilowatt hour of energy, you'll be getting back 200 watt hours from that. So, and there's also another aspect of how much solar cells can be integrated into the car. Yes. If so, I guess we can go through the case studies later. But for instance, Scion Sono motors, they've kind of integrated a lot of the solar cells within the chassis of the car through injection molding, and they're quoting about, I think, 50 kilometers per day, up to 50 kilometers per day, under the best conditions, I would say. So one thing you also have to note is a lot of these data that are out there are based on standard conditions. So that means it's 25 degrees Celsius C testing, 1,000 watts per meter squared irradiance. Any deviation from that will drop your output for sure.
So you mean if you live somewhere where it's only 10 degrees, for example, the efficiency will be lower? That's what you mean, right?
It would be. It depends on the actual solar cell. Sometimes it'll be lower, sometimes it'll be higher. But there are best conditions for the solar cell. So in terms of elevation in respect to the angle of the sun as well. That would affect how your solar panel generates electricity too. So for instance, if the irradiance angle is grazing, let's say close to 90 degrees from the side of the car, the only place you would be able to generate enough electricity would be on the side of the chassis of the body of the car. Because if you think about the solar cell, it's super thin. It's about 500 microns, around there. So any sort of light that goes grazing would simply pass through without generating any sort of electricity. So
do you mean the best place to put your solar panel is not necessarily on the roof?
The best place to put the solar panel is wherever you think the sun will hit your car at a direct angle. So that's why a lot of solar arrays, right, what they have is angle adjusters. They move with the sun. And that's a limitation for the car, because you can't have that for the car because they are actually tied into the body. So what you're left with is you either make a car that is so wide, like a dome shape, and ensure you get the best possible exposure irradiance, or you just blast the entire body with solar cells, which is kind of what Sono Motors have done.
Okay.
And if you look at Lightyear, what they've done is they've made the top of the car full of solar panels, solar cells, and made it slightly curved, so that will allow increased energy output from solar.
Okay.
So
I see.
Yeah.
And what about the degradation over the time? So this is the best solution when you start and everything is brand new. What can you expect in terms of how long it can last and make a good result? Are we talking about 2 years, 10 years, more?
Yeah. So in terms of traditional solar cells or solar panels for homes, the energy payback time has improved drastically. So you're looking at around maybe 2 years. But solar panels itself are guaranteed for, I think, 10 years, where they retain 90% of their efficiency. But generally, they can last you up till 25, 30 years. It's just whether you get the same energy output or not. So generally, you'll be looking at around a fast degradation of the efficiency at the first 10 years. Then as the solar cells degrade, the degradation rate reduces as well.
What about the dirt on this solar panel? Because I'm not the sort of person to wash my car very often, and sometimes
exactly. So exactly, that's a perfect example. Even something as small as that, as wiping the surface of your car, will affect the absorbance of the solar cells drastically. So if you're talking about general maintenance of the car, unless they come up with hydrophobic coatings where, during rain, or you just have to hose the car with water and it'll be self-cleansing in some way, then having solar panels on the car could be a lifestyle change for some people, where they actively have to wipe the surface, just to make sure it's pristine. You can't have any. Exactly.
would have to wash my car. So maybe some basic principle. I know you are super expert, but maybe for the audience, some basic principle. I'm not very familiar with all the technology on solar panel. I have the impression it's like a battery, in the sense that you have small bricks that are put together until you have a big solar panel.
Exactly. That's exactly the right analogy. So like a battery pack in an electric vehicle, solar panels or modules are made up of several different cells. So when labs or researchers talk about solar technology, they're referring to a single cell most of the time. But when bigger companies like product people who actually sell the modules, they're talking about the bigger ones.
Like some stupid question on my side. Imagine you have this on your car and you got an accident. If one of these cells is damaged, does it mean that everything shut down, or they still can work with a part of this damage?
It would kind of depend. Well, they're all in series, so it will also kind of depend how the actual electronics are set up by the manufacturer. But definitely, if you destroy one, it would severely impact the efficiency of the solar panel.
Well, that's not good news, because as you know, something damage on your car. I mean, on the roof, usually your roof is fine, but on the side, you can very quickly get a bump or something damaging.
Exactly, and I think that's one of the. It depends on the thickness of the material. So a thicker the material is, for silicon at least, the more brittle it is. The thinner you go, the more flexible it can become. And that's what Lightyear and what Sono Motors have done, is they've made 50 microns, I think, around their thick solar cells. So that way you can become semi-flexible, but not fully flexible. So I think it's about 15 degrees bending radius. So you can only bend so much for them to be able to mold the curvature of the car.
So we go a little bit in the case study, and you seem to have a lot of experience on the Sono car. Can you explain a little bit what is specific about these technologies and how they have a range and what you know?
The way the Sono Motors car is different to others that we've seen is that they have integrated the installation of the solar cells in the actual manufacturing process of the chassis of the body of the car. So they say that they do injection molding with the solar panels. So I'm not sure if people are familiar with injection molding. It's basically you have a little mold, you shoot a hot blast of plastic into it that forms the shape of whatever you're trying to make. So they're saying that they can integrate solar cells within that injection molding process, which solves a few issues. One of them being, how do you integrate solar cells within the car? Do you simply just stick it on, or do you find a more permanent solution? And what they've also done is, instead of glass, which is what you usually do to put on top of the solar cells to protect the surface, so any scratches would also reduce your efficiency, your output. They put polymer coating on top of the solar cells, so that also reduces the overall weight of the car. But interestingly, if you look at the Lightyear car, it's actually lighter than the Sono Motors. So, which tells me that the fact that they've put in a lot of solar cells kind of necessitates a different way of protecting the solar cells. Because I don't suppose you can have glass on the side of the car at all.
Mm-hmm. And do you know if this affects things like the security for the Euro NCAP or whatever collision, side collision, or, I mean, maybe for safety for driver or something, it gets some impact? I have no idea about that. Because today we don't have this car we have to remind people, this car, like the Lightyear and the Sono car, they are not commercial car for the moment.
Yeah, exactly.
Under development.
If it's glass, yes, it will pose an issue, but it would be the same as glass for your windscreen. I presume that would be tempered glass, so any sort of shatter would break them into pieces rather than, sharp bits. Just as you would.
Usually you do not have really the collision on the window. You have the collision on the chassis. For example, the pole collision will be dampened by the mechanical structure of the chassis.
Yeah.
So I guess here maybe change a little bit the thing. I don't know.
Yeah. So in that case, that is also, I suppose, the reason that Sono Motors have not put glass on the side of the car. They've opted for the polymer coating.
So I'm not that sure I understand exactly. On Sono, you say do they use the same technology of solar panel everywhere? Is that the same on the roof?
It is the same. So it is interbat connected single crystal modules. That means that if you look at a traditional solar cell at home, you would have lines across it. Yes. Those are metal contacts. So what they've done is they put the metal contacts behind at the back of the solar cell. So that means that even though it may not seem like much, that metal contact is also preventing the amount of light that goes through the solar cells. So a single cell may not affect it that much, but if you scale it up, that number becomes quite big.
I also think the surface, they say, so this is what you've given me, but they say about 7 square meters of surface.
Yep.
Nearly everything around the car. Yeah. But that's a lot, because if you see the efficiency of 1 square meter, getting 7 square meters, for me, is a lot.
It is a lot. And I think that was the reason they can quote something like you can go 1,000 kilometers without needing a single charge, as one of the case studies in Munich. Yeah.
And do you have an idea of the additional weight it represents? Because one of the problem of EVs they're already super heavy. So if you add in addition the weight of solar panel,
it's very hard to say how much it would actually weigh if I don't know the actual thickness of material they have. The weight of the polymer coating. I can't provide any educated guess on how heavy that would be.
So for the rest, I don't know if you want to mention things about the way to use it or other additional information you can get on the Sono Motors car.
No, I think I think maybe it'll be useful to go through the other cars, because we can kind of extrapolate what they've done with the Sono Motors and do a little comparison.
So if I understand correctly what you've explained here, so Lightyear does not use the same technology as Sono Motor, right?
Actually, it does use the same. It uses the same IBC single crystal solar cells as Sono Motors. In that case, there is no difference in technology, only in what they've done to protect it in that sense. So they've used a glass cover instead of a polymer coating. So glass.
So they use the same solar panel, but the coating is different.
Yeah. Exactly. And it's interesting that they've only have a 5 meter squared PV surface area, but able to generate more range from it. And my guess is because the car is more aerodynamic, so the energy consumption becomes a bit less.
Yeah,
so if you convert it.
A very good drag force. We have a discussion in the last episode with Wouter from Air Shaper, and he studied also Lightyear, and they have a very good aerodynamic. I also personally prefer the design of this car rather than the Sono Motor. Sorry to say, the Sono Motor for me is too square and it's difficult for me.
Yes, although I'm not sure I am more attracted to the €150,000 price tag of the Lightyear.
We can discuss about that later. So then we have some other cars that are more futuristic. So we of course also discussed this in the last episode, because as you can see, the design and the shape of this car called the Aptera is very different. But what do you know about this car? Are they using the same sort of technology, coating? What can you say?
Couldn't find anything about it, to be honest, anywhere. They've been quite hush-hush, but it's likely to be silicon. I don't see them using any other technology simply because the other technologies are the infancy. So if you look at other higher performing solar cells, they're way too expensive for them to be able to, first of all, way too expensive, and the infrastructure isn't ready for them to integrate into the car. So based on what they've quoted for the extra range, it seems reasonable that it's still silicon.
So when we compare these three cars, we also can see, and you mentioned that price can go quite high. So the Sono stay, I'm going to say normal, affordable car.
Yeah.
But the other one are more expensive. Do you believe this is realistic to keep this, I'm going to say, cheap price for
exactly. That's the question I was asking myself, is how much of this price is actually subsidized just for them to be able to break into the market, or how much of it is it's the real cost of the car, based on the real cost of the car that they would be offering that's not on pre-order. I think it's gonna be, I think like with any technology, there's a lot of investment and R&D. So that would probably have factored into their cost. But I guess I'm not in a position to talk about their business operations or financial model. But I'm not sure if that price is sustainable.
So let's talk a little bit about the material science, and I guess here you are very expert. What can you tell us about, if you could make other modification and other work on the ideal material, what would it be?
Theoretically speaking, the ideal material would have certain level of properties. So if you look at a material, it's made up of the electronic structure. And when I say electronic structure, it's just the way electrons orientate themselves within a material. And electrons are charge carriers. So there are certain levels within the material where there is called a band gap. And that band gap is essential for solar cells because it determines what wavelength can be absorbed by the solar cell. So what wavelength of light can be absorbed by the solar cell. Silicon's at 1.1 electron volts, but from theory, the ideal band gap would be 1.4 electron volts, so equating to about 885 nanometers of wavelength of light within the visible spectrum.
But that would mean change of material. That would mean, because today most of the solar panels are based on silicon.
Yeah, and the reason silicon is so popular is because it's very abundant in the Earth. The existing infrastructure is there to fabricate silicon wafers from the electronics industry. And it's not a bad material by any means. It's just not the best material.
Okay. I don't know, would you work also on other things? Like you mentioned several times the coating, you mentioned several times. Is there any other things to gain here?
Well, the ideal material also allows you, so there's one thing that we can talk about is whether they are direct band gap or not. And I'll just say as much as direct band gap is that if it's a direct band gap material, you can go thin. That gives certain advantages because the thinner material is, the lighter the solar cell would be. And hopefully the thinner it is, the less infrastructure is needed to produce it. And also it opens up new opportunities on how you can fabricate it. For instance, one of the material that I worked on is called perovskite material. And what you can do is you can literally dissolve it in a solution. You coat it on a surface, let it dry, and I'm oversimplifying it, but you dry, and you do several layers of other materials just to build up that solar cell. And then you can actually theoretically create a solar cell from simply painting the material onto a surface.
So in the future, in some scenario in the future, could we imagine that just the painting of the car could be on itself the solar panel of the car?
Could very be, yes. That's not far-fetched. It's just how much money are we willing to push in that industry, right, for that to happen. There are available technologies out there or research groups that deal with that solar paint.
When we prepare this episode, you also put this picture of solar panels that can be transparent, and this is something we have seen on some, high-tech forum or high-tech website, where they say you can make now a solar panel transparent, and we can imagine to get any window in your house, but also in your car. It could also be a solar panel. Is that existing? Like you can use this technology today? It's available?
I don't know if it's commercially available, but it's theoretically possible, and I think in the labs they have done it. The way I've done it is, so the way a transparent solar cell can work is a traditional solar cell absorbs visible light. That's why it's dark in color. That's why it doesn't show any sort of color, right? Because it absorbs the color that you're seeing. But a transparent solar cell absorbs wavelengths of light that are outside the visible spectrum. So that's why it still appears as transparent, but in the eyes of the solar cell, it still absorbs light. And in this case, it's likely to be either UV light or infrared light. Okay. So if it's infrared, you can actually keep, if you implement it in a car, you can keep the passenger cool. So on a hot day, you don't have to power up your cooling system. You can just have transparent solar cells coated on the window to generate electricity while not powering up your cooling system.
So before I hand everything to Tom, one last question from my side. Do you believe that solar panels are going to play a higher role in EV technologies? Would it be for charging station? But my question is mainly for integration of our car. Do you think we will see that more and more?
I think we will see that more and more because solar, if you think about it, is free. It's just the technology that harnesses it is not. It's ultimately is whether we want energy freedom and how much we can pay to make that happen. In terms of a solar cell powering a electric vehicle, on a day-to-day basis, that's not possible. For me, I believe it's only a range extension, and it helps keep the load off. Well, it helps you feel like you're doing the part for the world by harnessing electricity from the sun, and I think that's fantastic. I think all houses should also have solar panels, but it's whether the materials that we invest in would see enough use. For instance, in the UK, in London, if we do a map of the solar output of the sun on the UK, it's relatively low compared to those closer to the equator, of course.
And do you mean we don't have the best weather? I don't believe you.
Well. I don't want to say anything bad about the UK. But yes, so it depends on the location. It depends on how much you want to invest in. For me, if it's in the UK, it would be great to have, but not necessary, because you wouldn't see that much of a power output, energy output from a solar cell.
And just as an order of magnitude, are there a lot of differences between the result you would get in UK and the result you would get, let's say, in Italy or in Spain? I mean, this difference.
Yeah, I think it could be about 1 to 2 kilowatt hours per day of difference. So in a year, that's about 1,200.
Yeah, but the car, like 10 to 15 kilowatt-hour for 100 kilometers. So that
but you also have to consider that it's the actual usable period of the solar cell would be midday, and the persistence of cloud cover as well plays a part.
And just a last question, is that making any difference to collect the solar energy if you are driving your car? Because the problem is that you may recharge while your car is parked, but the problem is that you use your car usually the day, and if you park your car the night, it makes no sense to get the solar panel. So can you really efficiently recharge your car while you are driving?
I believe, I don't know about Lightyear, or I don't know about the electronics of Lightyear or Aptera, but from what I've read,
from the solar panel point of view.
Yeah, from the solar panel point of view, you can theoretically charge. I mean, it's just, so if you do a quick calculation, a day of driving will give you about, I think 0.44 kilowatt hour, I don't know, something like 4 kilowatt hours a day of solar charging. So that equates to about, don't know, 20 miles, 30 miles, which is not a lot, which is not, it's not small, but it's under the best conditions as well.
Okay, thank you. Now it's time for Tom to get some questions for you. So see you later on my side.
Thank you, Cecile. I think you've actually covered a lot of the questions that we've already been submitted on the way through. I think there was a lot of interesting topics covered. So how do solar cells degrade? I think we've covered that. Can solar cells be painted directly onto cars? I think you said yes in principle.
Yes, in principle you can.
The technology exists in the future. I think one of the best biggest items that automotive OEMs are contending with is always cost, and so all of this embeds cost into the system ultimately. So expanding into another question around, if you look at the whole thing as a system, a bit like we were just talking there, you know, if we're going to invest as a planet, if you like, into solar energy, are we better off adding solar panels with all the limitations that go with installing them into vehicles, or putting them into areas of high insulation, like near the equator, and then pumping them across large DC connections, sending the energy across the grid? What do you think? In balance, what would you do?
What I do, huh? Well, first of all, I don't know how much it would take to invest in having that solar generator concentrated around the equator and then having it pumped to the UK or other parts of the world. But perhaps there could be other ways of energy generation that wouldn't require that level of infrastructure, which I can foresee would be susceptible to a lot of geopolitical and geographical issues. So perhaps things like fusion, which I recently have seen quite promising news, or even nuclear energy. The issue about with nuclear energy is just the waste recycling.
Classical fission, yes.
Yeah, exactly.
Yeah. Fusion's the dream. We've got a big fusion device in the sky as well. So.
Oh yeah, that's what we're using to power the cars.
The other question is, so talking about, I guess, the new technologies with potential. So the transparent solution, where you're operating outside the visible light spectrum. So the efficiency figures quoted there are getting towards 50%. So double what we see with the silicon technology. So the efficiency is high, but is there enough energy available in those wavelengths?
Yes, I believe so. Yes, for sure there are. Well, it's kind of two-pronged, right? You don't just want to invest in solutions that grabs one spectrum of light. You want a solution that grabs all spectrum of light. And that transparent solar cell fits multi-purpose use in terms of generating electricity and cooling whatever they're covering.
So you get the win. You get the win-win.
Exactly.
Yeah,
exactly.
Yeah. That makes sense. And I think we've probably all witnessed the amount the cabin warms up when you leave a car parked on a hot day. So there's got to be potential there, isn't there? I think we've covered all my other submitted questions. So I suggest, given that we're approaching 45 minutes, we bring it to a halt and say thank you very much, Jonathan, for your time. And there was some great insight there into the tech that could be applied to cars, at least.
Solar painted cars.
Solar painted cars, yeah. Solar painted everything. I guess, yeah, we've seen it kind of emerge tactically and disappear again as well, haven't we? So I was thinking about Nissan Leaf. So Nissan Leaf had little solar panels on the rear spoilers, actually, but they've since disappeared.
I think a lot of the solar panels that the mainstream cars have done have only been able to used to power auxiliary electronics.
Yeah,
not the main battery.
No.
Yeah.
And just one question: when do you believe we will get this technology available on commercial vehicles? Because Sono, I think they say 2023, but it seems to drift. So do you believe we will see that soon? I mean, it's already available there at Ioniq 5, for example, on the Hyundai, but something like would power more range, I mean.
Hopefully soon, but I'm not holding my breath. Hopefully soon.
Okay.
I'll be very interested to see how it performs in real life, because I think it is a step in the right direction, and every small step we take is also a step in the right direction, because from that other people will be able to innovate more and create better solutions around that. So there could be something that we haven't thought of that, once that's out in the market, people start innovating.
I know that Ademaca made a review of the advantage and the efficiency of the solar panel on the Hyundai Ioniq 5. But I think it's not available publicly. But for those who are interested, I know this study exists.
Wonderful.
I guess one of the things we didn't talk about was HGVs, where there's possibly a more practical application. In the use of solar refrigerated transport, there's certainly practical and a couple of operating in those spaces.
For sure, I think there is quite a lot of opportunity for that. Yeah. Well, any sort of large real estate, if you can slap a solar panel on, will be perfect to power any sort of electronics that you have.
Yeah, makes good sense. Right.
Wonderful. Okay. Thank you very much, Cecile.
Thank you very much.
A pleasure.
A quick reminder to everybody before we go.
Do not forget to subscribe to our channel because we need some support.
That's right. Don't forget to subscribe, and you'll get the alerts for future episodes. So
I'm still not used to say subscribe, but apparently you have to say that on social media.
You do get an adrenaline rush whenever you see a new subscriber, don't you?
See that. Waiting for the numbers to go up. Yeah.
It's a waiting game.
Bye,
all right.
Everyone.
A pleasure. Thanks so much.
Cheers.
Bye.